This lesson will be our day one of a new section called 2.3, because we just finished 2.2. So 2.3, rewriting quadratic functions. And I'll give you a second to go ahead and get your board notes started. Nice fresh page in your notebook. Highlighters would be a good idea. If you need to go get those things, go ahead and press pause. When you're ready, come back. So 2.3, rewriting quadratics. We are actually going to learn to do just that. We're going to rewrite from one form to the other. And some of this we're actually quite familiar with. So the first rewrite we're going to practice is intercept to standard form. Intercept to standard. And the best way to practice is with an example. So number one, given f of x equals negative, and then in parentheses, x minus 4 times 3x plus 7. So I am given intercept form, and I'm asked for standard. And mentally, remember, what is standard? Standard is ax squared plus bx plus c. So this is ultimately our goal. To accomplish that goal, we are going to first distribute out these two factors. So leave negative 1 that's out front alone. That's going to just chill out front for a little bit. Negative is going to stay. And we're going to use our arrows to distribute. So x times 3x is 3x squared. X times a positive 7 is plus 7x. Next, we'll move to distributing the second term. Negative 4 times 3x is negative 12x. And then last but not least, negative 4 times a positive 7 is negative 28. Inside parentheses, I look to see if there's something I can do, and there is. Do you see it? What can I do inside? I have a positive 7x and a negative 12x. We can combine like terms. So again, this negative sign is just going to stay out front. On the inside, I now have 3x squared. Positive 7x minus 12x will be negative 5x or minus 5x. And then minus 28 will stay. There's nothing else on the inside of parentheses that I can actually simplify. So now we are ready to distribute this negative. And remember, when we multiply by negative 1, none of the values change, just their signs will change. So this becomes negative 3x squared plus 5x plus 28, and I'm done. So we started with intercept form. See our two factors? We started with intercept form, and we end with standard form. And we accomplish that by first multiplying our factors together, foiling these out. And then after we finished working on the inside here, combining like terms, when there's nothing else I can do on the inside, then I distribute my negative and I'm done. These are equivalent functions. If you were to plug this one into your graphing calculator and this as a second equation, it would be the exact same graph. We have just rewritten it from one form to the next. Number two. Number two, f of x equals 1/2 x minus 8 times 2x minus 9. So the process is still the same. What are we going to do first? We are first going to multiply out or distribute, FOIL, however you like to see it, these two factors. Leave a alone. A is 1/2. A is going to stay out front. So go ahead and pause the video right now and please distribute out these two factors and see what you get. When I multiply, it'll be x times 2x is 2x squared. X times negative 9 is a minus 9x. Now we'll send in our second piece here, negative 8, our second term inside. So negative 8 times 2x minus 16x. Negative 8 times a negative 9, positive 72. I need to check on the inside, is there something I can do first? Yes, we can combine like terms. I have a negative 9x and a negative 16x. When I combine like terms, again, leaving 1/2 on the outside, 2x squared is still here. Negative 9x minus 16x is what? Negative 25x plus 72. Now that there's nothing else that I can combine on the inside, we're ready to distribute 1/2. So 1/2 times 2x squared, half of 2 is 1, so I know that this is x squared. Another way of seeing it, 1/2 times 2 is 1, but we don't have to write the 1. Next, 1/2 times negative 25. Well, this is not an even number, so I would accept two answers. I would either accept minus 25 halves x, I would accept that, or you can move to a decimal form, which would be 12.5, so minus 12.5x, whichever makes you happy. And then last but not least, 1/2 times 72. Mental math, half of 70 is 35, half of 2 is 1. Adding those together, 36. So I know 1/2 times a positive 72 is plus 36. And I'm done. Again, we have successfully moved from intercept form to standard form by first multiplying or distributing out our factors here. And then once that was all done, all like terms combined if possible, then the last step is to send in your A value if you have one. Very good. Next. So that was intercept to standard. Now we're going to practice vertex to standard. Vertex to standard. Again, standard, mentally, we need to, when we hear standard, ax squared plus bx plus c is the goal. So this will be number 3. Given f of x equals 3 times x plus 4 squared minus 9, my job is to rewrite this from vertex form into standard form. Any thoughts? Well, let's see. I know that I can write this as 3 and then x plus 4 times x plus 4 minus 9. I know that I need to work with this first. From the last section, if we remember our rules, that if I have x plus b squared, that's x squared plus 2b plus b squared. We can use that rule here. So right away, I know that this will be 3 times x squared plus 8x plus 16. I need to amend that a little bit. There was an a involved. So let me back up. Here, a is 1, so it really doesn't matter. But if I had this going on, it would be ax squared plus 2ab plus b squared. If you're not comfortable with that, use your arrows, combine like terms, and you should end up with x squared plus 8x plus 16 on the inside. Minus 9 is still on the outside. We're going to distribute a. So 3 times x squared is 3x squared. 3 times a positive 8x is a positive 24x. And then we have 3 times a positive 16 is positive 48 minus 9. The last thing for me to do is what? What can we combine? Positive 48 and a negative 9. Those are like terms. So my final answer will be 3x squared plus 24x plus 39. Number 4. F of x equals negative 2/3 times x minus 6 all squared plus 11. Again, a will stay out front. We need to work on x minus 6 times x minus 6 first. For those of us comfortable with the rules from the last section, we know that x minus 6 times x minus 6 will be x squared minus 12x plus 36. If we don't like that, we're like, no, I want to use my arrows. No problem. X times x is x squared. X times a negative 6 is a negative 6x. Negative 6 times x, negative 6x, negative 6 times negative 6, positive 36. And then notice, combine your like terms, negative 6x minus 6x, there's my negative 12x. Either way, good for me. If you want to show that out, no problem. If you're good to jump and use those rules we learned in the last section, that's cool too. Now that I've combined like terms, we need to distribute in our negative 2/3. So negative 2/3 times x squared will be negative 2/3 x squared. Negative 2/3 times negative 12x. If it helps, I would do a little in-between work here. And I'm literally going to write out negative 2/3 times 12, and I'm going to choose to write that as 12 divided by 1, x. And same thing, for this next term, I'm going to write it out. Negative 2/3 times a positive 36. Negative 2/3 times 36. I'm giving my brain something to work with, something to see. Oops. So negative 2/3 x squared will stay. Let's work on multiplying fractions. I know that with multiplying fractions, I can just multiply straight across, but it might be nice to see if there's something we could simplify first. 3 goes into itself once, and into 12 4 times. Let that alone for a second. Come over here. 3 goes into itself once, and into 36 12 times. So now when I actually go to do my multiplication straight across, this becomes a lot nicer. Negative 2 times 4 is a negative 8. 1 times 1 is just 1, so I don't need that. So negative 8x. Here, 1 times 1 in the denominator, I know I'll end up with a whole number. So negative 2 times 12 is minus 24. If you choose to write divide by 1, go ahead. Just realize that that is equal to negative 24. And then I add 11 to finish this up. My last step will be to combine like terms. So our final answer here will be negative 2/3 x squared minus 8x, and then negative 24 plus 11 will be negative 13. And we're done. So looking at our first two rewrites, going to come back over to our first page. Intercept to standard, it was multiply these out, distribute A. Vertex to standard, very similar. Realize that I need to write this twice. Again, multiply these out, distribute A, and then just this last piece of combining like terms. A lot of similarity there in the process. FOIL, distribute, whichever word you like, send in A, combine like terms. All algebra we're very familiar with, maybe just in need of some practice. And tonight's homework will have you practice that. But to move from standard to vertex, which is what we're about to talk about. So starting with standard and going and rewriting into vertex, that's going to require a new skill we haven't learned yet. This will be the new learning for today. It's called completing the square. I'll say complete. Complete the square. I'm being picky. I should stop. Complete the square. Completing the square is how we're going to accomplish moving from standard to vertex form. So complete the square, process, the definition. It's a process that allows us to rewrite a function as a perfect square trinomial, as a perfect square trinomial. To complete the square. So we'll use CTS as an abbreviation, complete the square. To complete the square, you need to find a new C value using C equals B divided by 2 squared to obtain x squared plus bx plus that new C value. And we'll practice this. Let's practice right now. Directions. Find the value of C that makes the expression a perfect square trinomial. Then write it as the square of a binomial. So find the value of c that makes the expression a perfect square trinomial, then write it as the square of a binomial. So let's see what that looks like. X squared plus 10x plus c. So I have this unknown c value. So we're told find the value of c that makes this a perfect square trinomial. We're going to follow this process. We're going to take 10, divide by 2, and square it. Equals 5 squared, which is 25. This is how we would use this off to the side. But I would actually like us to have a habit of going right underneath where you see B and doing it right there. So 10 divided by 2 is 5. Squared is 25. So if we were to make this an empty spot where C is, 5 squared is 25. So that's the answer that goes right there. Now, to write it as the square of a binomial, we're going to pay attention to what you got in parentheses right here. 10 divided by 2 equals 5. That's the value we're going to use to write it as the square of a binomial. X plus 5 squared. So the C value is 25. And writing this as a perfect square binomial, we're going to take that value that you squared inside parentheses. Here I highlighted it, which is 5. That's what I pulled to write my perfect square binomial. And if you actually multiplied this out, I'm sorry, not perfect square binomial, the square of a binomial. See, square of a binomial. If you were to actually multiply this out, x plus 5 times x plus 5, you would end up with your original quadratic. Let's try another one. Number 2. X squared minus 7x plus c. But as soon as I see that unknown, I'm going to erase the c, and I'm actually going to put a blank. We're trying to find this value. The process does not change. We're going to take our b value, negative 7, divide by 2, equals 3.5. And I need to square that to find my value. 3.5 squared, or 3.5 times 3.5, is 12.25. And I'm done. That's the C value that makes this a perfect square trinomial. And now to write this as the square of a binomial, I pay attention to what I actually squared, which was the 3.5. So my answer will be x plus 3.5 squared. Now that we have an idea of what it means to find this C value that makes this a perfect square trinomial, let's actually practice one. And off to the side, we're going to take some notes. So this is our first official example of completing the square. Given f of x equals x squared minus 8x plus 11, write in vertex form. So we're moving from standard form, standard, into vertex. So standard into vertex will always be complete the square. Always, always. As we work on this example, we're going to take some notes on process to the right. So work on the left, notes on the right. Instead of f of x, let's write y equals. So y equals x squared minus 8x plus 11. Rules. First, a value must a value must equal 1. Has to. Has to, has to. So if I look at this one, is A 1? Yes. At the start of tomorrow's class, we'll actually look and see what happens when A is not 1. But for our purposes, we're starting with one where A is 1, so we're in good shape. So that checks off. Next, move old C, find new C. So move old C, find new C. And to do that, we're going to do that process we just talked about. But notice, I need a blank here, right? We're going to find this value, but this positive 11 doesn't just disappear. So let's get a line down our equal sign. I literally want to make a hole in this spot right here. So to do that, we're going to physically use math to make a hole. We're going to subtract 11 from both sides. This will become y minus 11, and I'm actually going to make, at the same time, a hole right here. So y minus 11 plus something I'm not sure about yet equals x squared minus 8x. And hey, look at that. I have a spot for what I need to find. Now, whatever we end up adding on this right side, remember, our equation has to stay balanced, which is why I made this spot right here. So whatever we end up adding as our new C value also has to be added to the left side. Now we're ready to find our C value, which we practiced in our last two. So we're going to take the B value, which is negative 8, divide by 2, that's negative 4, squared is 16. If I add 16 to this side, I have to add 16 to this side. If I want to combine like terms, this becomes y, we need to combine like terms. So negative 11 plus 16 is a positive 5, so this is y plus 5 equals, I now want to write this as a binomial, just like we did before, a squared binomial. So just like before, we pay attention to what did you actually square. I squared this minus 4, this negative 4. So my binomial is x minus 4 squared. Are we close to vertex form? We are super, super close. So just now, we factor. Factor the perfect square trinomial. That's what we did right here. Going from this to this was factoring the perfect square trinomial. Last step, isolate y. So if I do that, y is almost by itself. What's the only term that needs to move? This positive 5. So we're going to subtract 5 from both sides. Y equals, well, clearly, there's nothing alike about this. So exactly what I see written right here is what I'm going to write. Y equals x minus 4 all squared minus 5. And we have successfully completed the square and used that as a method or a tool to convert standard or rewrite standard into vertex form. I started with standard form, and look where we've ended up. I clearly have x, or a times x minus h squared plus k. Very nice. So tomorrow, we will pick up with examples, more examples of completing the square. If you look at the worksheet for tonight, there is no standard into vertex on the homework. That'll be for tomorrow night. Tonight's homework is practicing what we did at the start of the lesson. Intercept to standard and vertex to standard. So practice that for tonight. Tomorrow at the start of class, we will be working on some completing the square examples and organizing our thinking on what to do when. Have a great night. Please make sure you send me any questions on Remind. We will be picking up with more examples of our new learning on completing the square first thing tomorrow. Have a great day, everybody.